Okay, friends, let's see what we have here. First, of course, let's put our name on that, Mrs. Key. Let's see. The amount of water in a storage tank in gallons is modeled by a continuous function in the time interval 0 to 7. T is measured in hours, so that's that little swoopy thing. In this model, the rates are given as follows. The rate at which the water enters the tank, f of t, is at 100 t squared. The rate at which it leaves the tank is the 250, so that's this horizontal bar, and then the 2000. Okay. The graphs f and g intersect at two places. At time t equals 0, the amount of water. Okay, so we know there's 5,000 in the tank. How many gallons of water enter the tank during the time interval 0 to 7? So for entering the tank, enters the tank, that's the f of t. So integrate from 0 to 7, because that's a rate at which the water enters the tank, of f of t dt. So I just push some buttons on my calculator, and that's all I need to do. And when I do this, I'll put the f of t function into y1 so that I don't have to type it in over and over and over again, so I can reuse it. So the answer is 8,264 gallons. And then for B, for 0 to 7, find the time intervals during which the amount of water in the tank is decreasing. Give a reason for your answer. Okay, so the amount of water is decreasing if the derivative is negative. So the derivative is the rate in minus the rate out. We want that to be less than 0. Another way of thinking that is f of t is less than g of t. And I know that's 1.617. So from 0 to 1.617, it doesn't really matter equals or not. That is when f is less than g. And then from here until here, and from, let's see, that's 3. So from 3 until the 5.076. So those are the places where f is less than g. You can see that on the graph of what's going on. And my reason is right here, so I already gave my justification and then my answer. So I have fulfilled my needs there. 0 to 7, what time t is the amount of water the greatest? So amount is greatest. Let's see, possible at endpoints. You don't have to write that part, I guess. And where derivative is 0. So f of t minus g of t equals 0. At the 617 and 5.076. Oh, we also need or undefined. Undefined. F of t minus g of t is undefined at t equals 3. Now, both of these are mins because f minus g goes negative to positive. Because we just discussed that we were negative here and we were negative here with the f minus g thing from part B. So I don't need to pay attention to that. So really I just need to consider the endpoints, 0 and 7, and then 3. So at 0, we had 5,000. At 3, we're going to have 5,000 plus the rate in, f of t, minus the rate out, which is 250 dt, and that's from 0 to 3. And do that on your calculator, and you'll get 5,126,591. Having that in for y equals is helpful in that. I suppose I didn't need to integrate the 250. I could have just done 250 times 3 because it's a rectangle, but I didn't. And then for 7, it's the 5126.591 plus the integral 3 to 7 f of t minus the 2,000. Again, I don't need to put the 2,000 in the integral. You could just do 2,000 times 4, because that's the difference between 3 and 7. And if you do that, you get 4513.807. So what time is the amount of water in the tank greatest? Amount of water in tank is greatest at 3 hours. It doesn't ask me. Yes, at t equals 3, the amount is 5,127, because it says nearest gallons. All right, let's see what we have here. Oh, a slope field, okay. So when x and y are both 0, the slope is -1. So let's pick that one because that's easy. And then if y is 0, let's go with y is 0. Then I'll have 1/2 minus 1, so that'll be -1/2. And then if y is 0, I'll have -1/2 minus 1, which would be -3/2. If x is 1, then this is 1/2. And then 1/2 plus 1 minus 1 is just 1/2. And then 1/2 plus 2 minus 1 is 1.5. And then if x is 0, it's just y, so 1 minus 1 is 0. 2 minus 1 is 1. And then if x is -1, that's -1/2. -1/2 plus 1 minus 1 is -1/2. And then -1/2 plus 2 minus 1 is +1/2. Okay, so we did that part. Okay, so this means the second derivative. So find the second derivative. So I'll do the left side, that's easy. Then the right side, the derivative of x, 1/2 x is 1/2. The derivative of y is dy dx. The derivative of 1 is 0. So that's 1/2 plus 1/2 x plus y minus 1. Describe the region in the xy plane in which all solution curves to the differential equation are concave up. Okay. Solution is concave up if the second derivative is greater than 0. So 1/2 x, that should be an x, plus y minus 1/2 is greater than 0. Is y is greater than -1/2 x minus plus 1/2, right? So that's going to be kind of all the points above that line, because this is a line here. So I'm not going to write this part down, but you should write this part down. It's so that a line splits the plane into 2 half planes, and so it's the half plane above that line. It's basically probably what they're looking at for. Basically, probably. That sounds convincing. F is a particular solution, initial condition of 0. Does F have a relative min, max, or neither at x equals 0? Okay. F of 0 equals 1. F prime of 0 is So x is 0, y is 1 is 0. Okay, that's good. F double prime of 0 is 1/2, because I'm just going to go to there, because I know what the derivative is. So 1/2 plus 0 is 1/2. So that means that f has a min, because the second derivative is positive. Min at x equals 0, because f prime equals 0 and f double prime is greater than 0. So what that means is the curve has a horizontal tangent, so it flattens out, and then the curve is concave up. And if you picture that, or kind of hold your hand out, you can see what that is. Find the value of the constants m and b for which y equals mx plus b is a solution. So we know dy dx is 1/2 x plus y minus 1. Okay, so dy dx is 1/2 x plus y minus 1. And then we also know that y equals mx plus b. Well, doesn't that mean that dy dx is just m? So, alright, so I have these two equations. So that means that m is equal to 1/2 x plus y minus 1. But I know what y is, so let's plug y in. M is equal to equals 1/2 x plus y, which is mx plus b, okay, minus 1. Alright, so now I want to do this, okay. 0x plus m is equal to 1/2 plus m x plus b minus 1. Okay, what I did is I grouped things. So the x stuff has to match up. So 1/2 plus m is 0, which means m is negative 1/2. Who is a doozy? All right, and then m equals b minus 1. So the coefficient of the x's has to match up, and then the constant stuff has to match up, which means that 1/2 is b minus 1, which means that, not equals, b is 3/2. And does that answer the question? Yes, find the values of m and b. So that's a little tricky. This step here is probably the trickiest algebraic step because you maybe haven't seen it, but if you match up coefficients on either side of the equation, those pieces have to be equal. All right, let's look at this one. Continuous function f, define negative 6 to 5. We see the function f, so that is f. And quarter circle centered at 5, 3. So that's the center of the circle. And then it's known that 3 minus root 5 is on f. Okay, I assume that'll come into play somewhere. Negative 6 to 5 is 7. Find the value of negative 6 to negative 2. Okay. So, negative 6 to 5, this is part A, of f of x dx is 7. Can we calculate negative 2 to 5? So if we calculate negative 2 to 5, then that'll give me the, yeah, okay. So negative 2 to 5 f of x dx. Those two pieces cancel out, so I don't have to worry about them. Those two pieces cancel out, so I don't have to worry about them. So I just need to worry about this piece here, which is 1 plus 1 times 2 divided by 2. And then I need to think about, if you're wondering where I got those, the bottom part's a square, 1 by 1. The top part's a triangle, 1 by 2. And then this is a square that's 3 by 3. So plus 3 times 3 minus, I need to cut that circle out. So that circle has a radius of 3. So the area of that circle is 3 squared pi, which is 9 pi, but this is a quarter of that. So 9 pi over 4. So then that means the integral -6 to -2 of f of x dx is the whole thing, 7, minus, let's see, 3 times 3 is 9, 10, 11. 11 minus 9 pi over 4. And I don't have to simplify that. I didn't even have to make the 11. I could have written the 1 plus 1 times 2 over 2 plus 3 times 3 if I had wanted to. So I knew the whole integral, -6 to 5. And then I could calculate -2 to 5. So the leftover bit, if I subtract those, I'll write that down for you. You don't need to write this part, but if you want to. -6 to 5 of f of x dx is equal to -6 to -2 of f of x dx, pretend that's an x, plus -2 to 5 of, why is there a big parenthesis there, f of x dx. If I subtract that -2 to 5 from the -6 to 5, then I get the -6 to 2, -2, sorry. All right, evaluate from 3 to 5 f prime. Okay. Let's see, for part B. 3 to 5. I'm going to write this as two different integrals because I can and I feel like it. I don't know if that's going to be helpful, but it's worrying me. So, integral from 3 to 5 of f prime, that's just 2 f of x from 3 to 5. And then integral of 4 from 3 to 5 is just 4 times 2, because that's a rectangle. If you have the y equals 4, and then a width of 2. 2 f of x from 3 to 5, that's equal to 2 f of 5 minus f of 3. And then 4 times 2 is 8. So that's 2. F of 5 is 0. F of 3, is that the thing they gave me? Yes. F of, oops, not parentheses set, minus 3 minus root 5, and then plus 8. That's a weird number, but I'm just going to leave it there. The function g is given by that. Find the absolute max -2 to 5. Okay. So, for part C, g prime of x equals f of x. That's the fundamental theorem of calculus. The derivative and integral cancel out. And that equals 0 when x absolute max, sorry, I don't have to say equals 0, goes positive to negative at x equals 1. Also, check endpoints. So we want g of -2, g of, I wrote 1, but it's -1, sorry, -1, and then g of 5. G of -2 is the integral -2 to 2 of f of x, f of t dt, and that's 0. G of -1 is from -2 to -1, f of t dt. And then g of 5 is integral -2 to 5, f of t dt. -2 to 5, f of t dt, and we said that was 9, 10, 11, minus 9 pi over 4. And then we need to know from -2 to -1, that's a triangle, that's 1 by 1, so that's a half. That's going to be roughly 27 over 4, so I'll call it 28, so that's like 7. So that's the maximum value, because that's bigger than a half. All right, and then the last part, I'm going to zoom in and go over here. Find the limit as x goes to 1. Okay, so f prime of 1, that's that slope there. f prime of 1. Okay. So let me get rid of this stuff. F prime at 1 looks like 2. So that's 10 to the 1, which is 10, minus 3 times 2, which is 6. Then f of 1, which is 1, and the arctangent of 1. Okay? So I can calculate all that. Limit as x goes to 1 of 10 to the x minus 3 f prime of x over f of x minus the arc. See, I thought we were going to do L'Hopital. And that's just 10 minus 3 times 2 over f of 1, which is 1, minus the arctangent of 1. So that's asking you when is the tangent 1, which is pi over 4. And I could simplify that, but I don't want to. So I am done.